Hello students, how are you all? Today we are going to discuss how to find the acceleration or retardation from a given graph of velocity time. Here already I have drawn the graph. If you can see, it's a velocity time graph because you can see that the vertical axis means y-axis is indicating velocity, and the horizontal axis, that is time, representing time. So x-axis time, y-axis velocity, and this is the motion of that particular object. Let us discuss this in details. If you can see, first the object is traveling from A to B, then B to C, then C to D, then D to E. Now, we'll go step by step. First of all, see, the graph is not completed here. Say this is 15 meter per second, 30 meter per second, 45, 60, 75, 90. So this is my question. This complete graph is the question from which I have to calculate the acceleration and retardation of that object for its, like from A to B, B to C, C to D, then D to E. First we will work with A to B. A to B. To find the acceleration here, what we need to do, the formula is very simple. Acceleration A to B. Acceleration from A to B, you have to write the final velocity minus initial velocity. So when the object is going from A to B, which is the final position? A? No. B. B is the final, A is the initial. Yes. So what is the velocity here? You can see the velocity is 60. So final velocity is 60. What is the initial velocity? A, 30 minus 30. So final velocity minus initial velocity by final time minus initial time. What is the final time? Final 10. What is the initial time? 0, because this is time. 0. So 30 minus 10, that is 3 meter per second square. This is the acceleration of the object when it is going from A to B. Now we'll consider B to C. When the object is going from B to C, acceleration B to C, same formula. Which is the final position? B? No. When the object is going from B to C, C is my final position and B is my initial position. So what is the final velocity? 60 minus, what is my initial velocity? That is B, 60. Final velocity is also 60, initial velocity is also 60. What is the final time? 20. What is the initial time? 10. 20 minus 10. That is 60 minus 60 is 0. We know that 0 by something means always 0. 0 meter per second square. That means when the object is moving from B to C, it does not have any acceleration. That means the object is moving with a constant velocity. The velocity remains same. Acceleration is 0. Now, acceleration from C to D. C to D. Same formula. Which is the initial position and final position? Now when the object is moving from C to D, C is my initial and D is my final. So same way at D, what is the final velocity? 90. 90 minus, what is the initial velocity at C? 60. What is the final time? 25. What is the initial time? 20. 30 by 5, that is 6 meter per second square. Done? Now from D to E, acceleration D to E. When the object is going from D to E, so E is my final and D is my initial. So D is my initial and E is my final. Same formula. D to E, E is final. What is the final velocity? E. Final velocity is 0. You can see E is the final point. So final velocity is 0. 0 minus initial velocity. Initial is D. 90 by final time minus initial time. What is the final time? Final time 30. Initial time 25. 0 minus 90 minus 90 by 30 minus 25, 5 minus 18 meter per second square. Acceleration is negative. We know that when acceleration is negative means it's not acceleration, it is retardation, means it's decreasing the velocity. Yes, from D to E we are seeing that the velocity is decreasing here. First the velocity was increasing, the graph is going up, then graph is horizontal, means zero acceleration. The velocity is not decreasing, not increasing, remains same. Then C to D, again the velocity is increasing. Now D to E, velocity is decreasing. When velocity is decreasing, it's acceleration. No, it's retardation. Yes. That's why we got a negative acceleration here. That means it is retardation. Okay? Let us go for another example. Another example of velocity time graph. Here again we'll find the acceleration and retardation. Then we'll also find the total distance covered by the object. Yes, from this graph we can also calculate the total distance covered by the object. Let us see that. First of all, as we discussed in the previous numerical, from A to B, the velocity is increasing or decreasing? Velocity is increasing. So, can we find the acceleration from A to B? Yes, same formula. Acceleration A to B. Final velocity minus initial velocity. Which is the final? Is this the final? No, this is the final because the object is going from A to B. So B is my final, A is my initial. What is the final velocity? 60. Minus, what is the initial velocity? 0. Final time minus initial time. What is the final time? 15. What is the initial time? 0. So 60 minus 0, 60 by 15 minus 0, 15. That is 4 meter per second square. So this is acceleration by which the object is moving from A to B. Now we'll find from B to C. If I ask you, do the object have any acceleration from B to C? No. If you have understood the previous sum, we have seen that when the graph is horizontal, then the acceleration or retardation are not there. Let us find that. Acceleration from B to C. Which is the final and initial? This is the final and this is the initial. So what is the final velocity? 60. Minus, what is the initial velocity? Again 60. 5. What is the final time? 30. What is the initial time? Initial time is 15. 0 by 15. That is 0 meter per second square. So we have proved that. In the previous numerical also we have seen that when the graph is horizontal, it does not have any acceleration, that is acceleration 0. Here also we have seen the same thing. Now let us consider from C to D. Acceleration from C to D. Do the object any acceleration from C to D? We have seen the previous sum that when the graph is going down, that is C to D, it does not have any acceleration. It has got retardation, correct? Let us find that retardation. From C to D, which is the final? D is the final position and C is the initial position, correct? Now C to D, which is the final velocity? This is final velocity. Remember, this is the velocity line. Velocity is 0. Minus, which is the initial velocity? 60. 60 is the initial velocity. What is the final time? This is the time axis. Time 40. Which is the initial time? 30. So don't be confused while taking out the data for your velocity and time, because this is the axis which is representing all the velocities and time axis. Now 0 minus 60 is minus 60, 40 minus 30, 10, that is minus 6 meter per second square. So is it acceleration? No, it is retardation. So this is retardation because the velocity of the object is decreasing. Done. So we have taken out all the acceleration and retardation. Now next question is, from A to B, B to C and C to D, what is the total distance covered by the object? Yes, we will find the total distance covered by the object. Let's find distance. To find the distance, we have to see what is the shape of this figure, the complete figure. If you see, this complete figure is a trapezium, correct? This represents a trapezium. If I draw it separately, this figure, this is the shape. Yes, this A, B, C, D. A, C, D. So it's a trapezium. Now, if you find the area of this trapezium, that area will give you the distance covered by the object. Yes, the area of this shape is equal to the distance of the object covered. Let us find the area of that object. Now, this shape, since it's a trapezium, we know that the area of trapezium is sum of its parallel sides. Which sides are parallel? This side and this side are parallel. That means BC plus AD. BC plus AD sum of parallel sides into height. This height means this one. Say this is PE. PE is the height, or you can say see this is also height, or this is also height. BE by 2. This is the formula to find the area of a trapezium. Sum of the parallel sides into height. Height means the distance between parallel sides. Distance between parallel sides by 2 equal to. Now what is BC? BC means 15 to 30. That is 15 plus AD. AD means this complete one. 0 to 40. That is 40. Into BE. This height. BE. What is BE? 0 to 60. That is 60 by 2. I hope you understood this calculation. 15 plus 40, that is 55 into 230 into 30. 1650 meter is the distance covered by this object. So we have seen that from a velocity time graph, we can find all the acceleration, retardation plus the distance covered by the object. Now, if you see your textbook, you will find different type of graphs are there. You practice that. Sums are easy. Try those sums. Thank you.